Okay, recording the first couple examples of 4, they start us off with a common log, and common log is log base 10. So Matthew just asked, if there is no number here, we assume that it is 10. Your calculator, if you just hit the log button, it will be log base 10. Even though it doesn't have the 10 there, it will just automatically assume it's log base 10. So all of these guys right here that they want you to plug in for a calculator, those are all log base 10s. Okay, so this guy right here, if you do log base 10 of 1,000, you typed it in, and Ken's got 3 because 10 to the third power equals 1,000, right? Like that's what you're finding. So the answer to that is 3. Log base 10 of 142. If I guesstimate this real quick, 10 to the first power is 10. 10 to the second power is 100. 10 to the third power is 1,000, right? So if I'm trying to get to 142, 142 lives between these two numbers. So my decimal number is going to live between 2 and 3. Does that make sense? But closer to 2. Yes. What'd you get? 2.15. We'll go, I think we go like 4 decimal places when we do this, okay? 2.1523. That's what we get for the second one. Yes, I am. Okay. 10 to what power will give me this guy? It's probably going to be a negative exponent or a negative power. So just type in log base 10 of blah, blah, blah. 2342, and that makes sense. When you're making it into a fraction, like 10 to the negative first power is 1/10, that's 0.1, right? So if I'm going back and I'm doing decimals, I know that my exponent is going to be negative. I know my number is going to be negative. So this is negative 2.2342. There you go. Just typing numbers into your calculator and hitting the go button. Okay. Logs are used in pH. Logs are also used in like earthquakes. For the quakes, they're used in the Richter scale for earthquakes, and then they are also used in loudness, when they're talking about like the loudness of a guitar or something. pH, earthquakes, loudness. There's more than that, but that's like what logarithms are used a lot for. Do we know pH goes from 1 to 14? 7 is a neutral pH, right? If it's closer to 14, it starts to be like these are the basics, like a bases. It's a base, whatever. If it's closer to 14, it's acidic. If it's closer to 1, okay? So that's how that works. All right, a pH of a solution with this guy that is 2.5 times 10 to the 14th power. Use the definition of pH. Okay, pH is the negative log of that hydrogen ion, whatever, okay? So here, if we're trying to find the pH number, right? The pH number goes from 1 to 14. I'm trying to find the pH number if that hydrogen, what is that? I don't know, what is this thing called? H3O, trihydrogen oxide, is that what it is? Or does he have a name? Connor, do you know? H3O, does he have a name? What? Hydronium. Okay, so hydronium must have an atomic something of 2.5 times 10 to the negative 4th. If we're trying to find his pH, we do negative log. Why does that look like 10? Negative log of 2.5 times 10 to the negative 4th power. All right, here we go. When we do this, multiply means add. So this guy, if I try to separate him into pieces, he is negative log of 2.5 plus negative log of 10 to the negative 4th power. All right, let's chat about this.
We have to break it apart. Or can we just
You can just plug it into the calculator this way, okay? But if we break it apart, if we do negative log of 2.5, somebody do negative log of 2.5. I don't know why this looks like a 10. Negative 0.3980. Yeah. Okay. This, I don't know why that looks like a 10. It's not. It's a log. Okay. Hold on. Just wait. Log base 10. Hold on. Oh, you didn't get it. Okay. So negative log. What's log base 10 of 10? Like this guy is 1. So this is minus a negative 4. So this is just plus 4 because the log base 10 of 10 cancels. And then if I add those two together, you should get like 3.6020. That's what the pH of hydronium is. So it is
Not really.
more
Hydronium
acidic.
is the acidic factor of it,
Okay.
right? So
Okay.
it's just a solution.
Gotcha.
Right? So hydronium is like when you break down hydrogen, it either becomes H3O or HO, right?
Gotcha.
So H3O is kind of just a factor of it,
Okay.
factor of like something like that.
Okay.
So hydronium isn't the solution, like it's a random solution, we don't know what it is.
Gotcha.
Hydronium is just a factor that determines
Gotcha.
pH.
Gotcha. Okay. 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 All right. So there you go. Yeah, the hydronium ion concentration of a solution. Ooh, with a P. Where did he go?
I think you went back to
There we go. Okay. If he has a pH of 7.1, we need to figure out what his hydrogen concentration is. So now we're working backwards. So we have equals 7.1, right? 7.1 equals negative log base 10 of, let's call it x. So we're trying to figure out what this x is. We're trying to figure out what the H3O plus what that thing is, right? What the solution is. Okay?
This is when you divide the log.
So, no, because the x is trapped inside of the log. So we can't just divide log over. What?
Don't we have to put the log on the other side?
Kind of. I mean, no, not quite. Not quite. This guy is in log land, right? If we are stuck in log land and we want to switch to exponential land, that will help us solve him, right? So if I have this guy going on, right? I'm gonna kick this negative to the other side. Can we kick? Let's bump this negative over here. So let's make this positive. If we divide by a negative, let's make that negative 7.1. Okay. Now, if I switch him to an exponential function, what will he look like?
10 to the negative 7.
Yeah, 10 to the negative 7.1 power equals x. That's what our hydrogen concentration whatever is. Yeah,
So
that's it.
7.94 times 10 to the negative
7.94 times 10 to the negative 8 is what that thing actually is. Okay.
Is that when I need to put it in scientific?
8. I'd recommend putting in
Because I
scientific.
got like
If we're working with pH.
Gotcha. Yeah. Yeah.
you want to be in scientific.
So what this does is it converts this guy from here times 10 to the negative 7.1. It converts it to a whole number exponent. Well, not a whole number, a negative whole number exponent. If you put it in scientific notation, it'll flip it. Yes.
Guess the pH of Mountain Dew.
Of Mountain Dew.
Isn't it like 15?
Well, it can't go any higher than 14. What?
Thanks.
What is it?
3.
3. That's really acidic.
Incredibly acidic.
Wow.
Like when a guy complained that he found like a rat in a Mountain Dew can, they said no because it would have dissolved by the time they made it out of packaging.
Ew.
Oh,
That's what they say
Oh.
about all canned drinks. Like
Interesting.
100 Celsius and-
isn't that like bad for your skin if you're up there for so long or whatever?
So,
Like,
yeah, if you
Yeah.
like bathe in Mountain Dew, it's gonna hurt after a while. But also, I don't think you'd rather.
oh,
bathe
oh,
in Mountain Dew.
oh, nice. Okay, got it.
Okay, thank you.
That's
Interesting.
Are we done?
ridiculous.
Yeah. Mm,
You can give
yeah.
yourself a
Nah.
filter because the stomach acid gets too strong.
I want to know what the do you know what the pH is of like Coca-Cola, because they use those in a lot of cleaning products.
I can look
Look it up. They use Coca-Cola in a lot of cleaning products just because it's so like corrosive.
I think most cops are below.
it up. 2.5.
2.5, so it's even more acidic. Woo!
Well, have you drank Coke?
That's crazy.
What's Pepsi?
All of them?
Oh, the Pepsi's worse than
2.53.
Yeah, interesting. What is it? What is it?
2.53.
For what?
Pepsi.
Pepsi? Dr. Pepper, that's what I drink. Don't tell me. Okay, tell me. What do you got?
I gotta do it.
I gotta do it.
it's gonna be like 1.
I know, it's gonna be the worst one.
2.89.
Oh, that's
So it's all of those are even worse than Mountain Dew.
well, that's not good, but like it's better than 1.
Yeah. Yeah, I mean, right. Okay, all right. Okay, we'll stop there. La 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 la.